Hello everyone, this will be part 3 of the chapter 1 introduction. Today we talk about descriptive statistics. So it's a little deceptively small box here, descriptive statistics, visual and numerical summaries. But actually it's a very big and important topic. Let's start in the introduction of the book. I would like you to reread this section about what is statistics, and in particular make a distinction between descriptive statistics, which is focused on a particular data set and we have all the data we need. We want to make a summary of what we have. So summary, visual summary. But we're focused on what is in the data. And then the more complicated task, which is inferential statistics, is we have a sample from a wider population and we're trying to infer what we see in the sample and try to generalize it to the wider population. So this is for today, and this week we talk about descriptive statistics. There's a lot of formulas and stuff, but it's still concrete. We have the data, calculate this, summarize this. This is much harder, like an order of magnitude harder. This will take the whole part 2 of the book. But I wanted to start with this because when people talk about statistics, half the people, like sports statistics, finance statistics, people talk about just summarizing existing data sets. So that's what they're talking about. The other half of people, like professional statistician, when someone says statistics, they mean infer from sample to population. And it's important for you to know these two distinctions. Speaking of descriptive, let's jump to section 1.3. What is descriptive statistics is trying to compress a whole data set into just a few numbers. It's one section, but really it's 4 separate sections, because when we deal with numerical variables, we do certain things. When we deal with categorical variables, we do completely different things. So there's some overlap, but in general, we're doing very different tasks. So this is why you can read this section in parts. Numerical variables, the key ideas of mean, median, mode. Yeah, you read the book, a lot of interesting stuff. So we go over the theoretical with like math equations, then we revisit the same concepts with a particular with the score variable. So hopefully this will help you connect the theoretical notion of median and the practical notion of median. Yada, yada, yada. Histograms, this is a very nice picture, how to produce the graphs. Interquartile range, so these are the first and third quartile. This gives you an information where is the middle of the data. So here is the summary table for a particular data set. We can summarize, instead of looking at all the data, S is the scores data, we can summarize it using these 10 numbers. And these 2 numbers tell you where the center of the data is, where the middle. These 4 numbers tell you the dispersion, like are the data concentrated near here or are they like spread out? And these 5 numbers, called the 5-point summary, tell you split the data into 4 equal chunks. So it tells you roughly where the top half is the bottom half. The first quarter of them are between the min and Q1. Ignore these exercises. I'll send along a different, they'll be updated. Okay. Next, okay, I need to speed this up. We have two variables, two numerical variables. So everything you can do with the variables individually, you can do with the variables. You can separate them and treat the two variables separately. But there's other things like a scatter plot that you use both numerical variables and you plot the relationship between them. Well, there's a clear trend here, right? So that's the visual comparison. And then there's numerical concepts of covariance and correlation, which give you a measure of how linearly correlated the two variables are. Obligatory reminder that correlation does not equal causation. This is a nice picture too. Don't interpret the correlation value too much. So sometimes, clearly, all these figures have some pattern in them, but the correlation is almost zero. The reason is that correlation is only good at detecting linear association. So this is positive and this is negative. It cannot detect when, so this is a third order relationship between the x and the y. As far as correlation is concerned, it's like, it looks like a line. So you need to look at the graph. You can't just compute a single number, the correlation, and conclude your analysis. Okay, so then the next problem is when you have a categorical variable, a categorical predictor, and a numerical outcome variable. So that's the scenario we've been discussing before. We have two groups. In this scenario, we've discussed the debate in the lecture curriculum groups. You can calculate statistics for each group separately. You can plot scatter plots, histograms, all of that. Okay, so again, everything you learned from a single variable, but now we use the same statistics, descriptive statistics, for comparison of two groups. And that's how far we'll go with numerical variables. The next step is categorical variables. The concepts are frequency, counting the number of occurrences, and relative frequency, which is the frequency divided by the sample size. Tables of frequencies and bar plots. The function for producing this bar plot is actually count plot, but we call it a bar plot. Not very exciting, but you need to know how to do these things, because in particular value counts, this is a function you use when you use pandas. It's one of the most commonly used functions, so it's good to get to know this and its options. Then we have two categorical variables. So now we're counting joint frequencies. How many times does this pair in the data set? And the data is now pairs of variables. Okay, again, frequency table, so this is called a two-way table, and these are called the marginals because they're in the margin of the table. The total number of students in the lecture curriculum is 7. So how did we get that? We added up the row total to the margin. Combined bar plots. Then we can normalize things by row, by column, relative joint frequencies, and conditional joint frequencies. A lot of details, not super essential, but it's good to know how to generate these graphs.
It's 9 o'clock.
Okay. And that's it. So it's a pretty long section, but if you read it in chunks, like one subsection per day, you should be done with it. For each section, I'll have exercises. I've just tried the exercises. They take 5 minutes each. So there's a lot of exercise, but you can do them you sit down for 10 minutes, you're done. The end of the section, we describe some useful details. I don't know if you've noticed yet, but I skip some details when I explain because they're not. I want you to know these things, but when you're reading, I don't want to hit you with all the information at once. So explanation section, you should be reading. These are filling in some details that we missed through the section. Yada, yada, yada. This is another type of plot. Now the discussion, you can read if you're interested. So if I place some topic in a discussion section, if you're in a rush, you can skip it. But this is more like trying to connect the topic to other topics that are coming up, reading ahead, back references. But nothing essential is in the discussion. Like the discussion is bonus for if you want to know, for those who want to know. And the famous Datasaurus dataset. All of these data plots have the same statistics. And if you look at the correlation, it will be like, oh, there's no correlation. But look, clearly there are patterns. You would say like X is not associated with Y. But all of these show some clear pattern. It's just there is no linear correlation. The data points don't look like a line. So this is a famous data set from this paper that talks that, visual backing to the argument. Don't just trust the statistics. Always plot your data. Some more kinds of data visualizations. And that's it. All right, good luck with this. See you on Friday.